can be explained by the least squared regression line, and you can write LSRL between distance and fair. That's what we're looking for on the AP test. Those are the words we're looking for. What that means is that only about 49% of the time can the spread of the y values that you actually get out of this be explained by this line. So it's really only accurate about 49% of the time. So I probably wouldn't want to use this if I'm the guy who is responsible for figuring out what fair is going to be. It's only good about 50% of the time. I need to find another model because this is not accurate enough. I want more money. So that's not going to be accurate enough. All right, look at 3. 3 just simply said find the slope. Now we've done that. The slope is 0.078. All right. Then underneath that, it simply said find the y-intercept. We've done that. It's 177. Now it just says find them right now. You're going to have to interpret them in just a minute. All right. Now 5 is where you would actually write the equation of the linear model, which is the equation we have written on the board up here. So we would write our equation. Now, 6 and 7 ask you to do 2 things. It says estimate the fare for a 200-mile flight. And 7 says estimate the fare for a 2,000-mile flight. So you are going to use your model that you have created here. You're going to plug in the 200 and you're going to plug in the 2,000. So do that and figure out what the cost is going to be for a 200-mile flight and what is the cost going to be for a 2,000-mile flight. Because it's going to ask you to do something with these numbers in just a minute. All right, so if we're going 200 miles, what is our fare going to be? How much is our trip going to cost us? How much? $333. Did somebody else get that?
Yeah.
Okay. All right, and if we go 2,000 miles, what is it going to cost us? A little bit louder. 1,737. Okay. Do we agree with that? All right. Now, on question number 8 of this, and I would have printed this off for you if I knew I was going to teach this, but I didn't know I was going to do this today. On number 8 here, it says, using the estimates that you just did, the 200 to 333, the 2,000, the 1,737, draw the line of best fit. Now, one thing you need to realize is if they ask you to draw the line of best fit on the AP test, they don't mean look at your calculator and draw a line. They mean plug 2 points in, because it takes 2 points to make a line, plug 2 points in, and then graph them and draw a line. So for us, we're at 200 and 333. So we would plug in our points here, and then we would plug in our points of 2,000. Are we sure about this?
No, I don't think so.
I don't think so.
See, that shouldn't be right.
I got it.
This is awful high.
Yeah, because with our equation, I think our equation is
I
wrong.
got 192.7.
I think our equation's wrong because that's
the 333.
333 is
high.
higher than
I
what
got-
the 2,000 miles should be.
Yes.
Hey, I think the 333, I got that for 2000.
That's what I got.
Okay.
Exactly.
That makes more
And
sense.
then for
That makes more
Those
sense.
200, I got
0.78.
192.
Yeah, I got 192.6.
That's what I got.
Sorry, guys.
192.
No, it was the equation that was right. I think you just said that for the wrong one.
Alright, so let's plug these in because that makes a little more sense. At 200, we have almost $200. So we would have a dot there. And then at 2,000, which would be out here, we would be at 333, which would probably be somewhere here. Now, this is the only way to put the least square regression line on an AP test, is to take the equation and take 2 points. Now, you would generally take a point from the beginning, which they did, and you would generally take a point from the end out here, which they did, plug them in, and get your line. And so then, again, that's not very straight, but anyhow. You know, on the AP test, you're not going to have anything to draw a straight line with either. So my suggestions to you would be something like the calculator cover or something, if you have to do that. But I have graded these before. And so again, and I forget which year it is, but you actually have an example, one of your free responses from a couple of years ago. I asked you to do this. And the only way to do it is to get the equation first. Now I will say, a lot of the time when they ask you to do this, they're going to give you the equation so that everybody's going to get approximately the same answer. Because you could get all kinds of answers depending on how you rounded these things off. So they will generally give you the equation for that. Alright, so that would be putting your LSRL on there. Alright, so then 9 says, explain what the y-intercept means in the context of this problem. Alright, so here's our graph. What do you think the y-intercept of 177 means? Now again, what's a y-intercept at any given time? What's a y-intercept? When x equals 0. So if you're going to write what it means, you would put that when the distance, and you got to do it in context of the problem, when the distance is 0, the y-intercept or the fare is $177. Now, is there any logical reason for there to be a $177 charge? And then the next question needs to be, is 0 in our data set? You know, our first data point here is about 400. Now, what do you know about extrapolating? You got to know what that word means. What do you know about extrapolating? What does extrapolating mean? You do not extrapolate outside your data range. So the y-intercept is not in our data set. So therefore, we would generally tend to say the y-intercept here is irrelevant because it's not. But now you're going to have to, when it says interpret it in context, you're going to have to tell them that at 0 distance, the fare would be 177. But it is outside our data set and we do not extrapolate. And we would do the same thing here because a lot of times the next question might be, what if you had a distance of 3,000? Now you can give them a value, but your next statement needs to be, but we don't have much confidence in that because it's outside our data set. We don't extrapolate in here. And you need to know that word extrapolate because they look for that. Or you might see that in your questions as a whole. So again, we don't have a lot of confidence in that y-intercept there. Alright, let's see. Now, 10 says, what does the slope mean? Alright, so here's a slope. We generally put that over 1. And it is read as, for every 1 mile increase in distance, there is a 0.078 increase in fare. money and fare. You know, you could round that to 8 cents if you wanted to. That's fine. But again, you need to know those sentences and they got to be in the context of the problem. All right, so let's look at 11 and 12 because these talk about residuals. And we need to make sure we know what a residual is. All right, so 11 says the fare to fly to Los Angeles, 1,719 miles from Atlanta is 212. Find the residual. Now, what is the residual? What is a residual? Somebody tell me what a residual is. What's a residual? It's the error associated with the problem. All right, so let me scroll back up here and look at the graph for a second. All right, so we're looking at, roll back up. All right, so if our line is in here, and again, it's somewhere up there like that. Definition of the residual is how far is your point from the line. Now, it's some big long definition about the vertical deviation from the least squared regression line is the actual definition of a residual, but it means the error. So what you're doing is you're looking at the distance each one of these points is from the line. And you will see this on the AP test. You will have to calculate a residual. Now, the formula for a residual is error is equal to y minus y hat. Now, y being the value of your point. And so, in this problem, I don't even remember which point we're looking at. Let's see. Los Angeles. We could choose. I'm just going to choose Las Vegas here, right here. So, my y value is the fare for Los Angeles, I'm using Las Vegas, is $2.52. That's my y value. Now, you put in your calculator for Las Vegas 1,719 miles and tell me what the fare is that our line predicts. So find me y hat for Las Vegas there. If it's 1,719 miles, what is our y hat or our predicted value?
311.082.
So I'm just going to use 311. All right, so we are looking for the error here. So we're going to take what our actual value is, and we're going to subtract from it 311. Now, subtract that and tell me what we get. Negative $59. Now, what does that mean in the context of this problem? Because it's all about the context of the problem. So what does negative $59 mean?
The actual value of the ticket is $59 less.
Yes. Now, you might also see the words that the line is over predicting. That's another way they'll put that in multiple choice questions. So you may see it written in that format as well. The line is over predicting, the line is under predicting. So just know that may be other words that you will see there. All right. Then the last two things here, just say, in general, what does a positive residual mean? And in general, what does a negative residual mean? Which is kind of what you were telling me over there, that a positive residual means you've paid more for the fare than you should have, or what our line was predicting. A negative residual means you got a bargain. Now, from the consumer point of view, a negative residual, here's a great thing. From the airline's point of view, I'd much rather have a positive residual because I'm making more money that. And so you have to be careful in the problem because we did one the other day from the customer's point of view. We were buying diamonds. And would you want to be a negative or a positive residual? So you got to look at who they're asking the point of view from. Is it from the customer or from the seller? As to which one you'd want to know. But you will see residuals on the AP test. They're going to be there. But not a lot, but they will be there. What's the one final way that you know beyond a shadow of a doubt that your line is linear? What's the one thing you can do? If you're in doubt as to whether or not you truly have a linear fit, what's the one last thing you do to check that? It has to do with your residuals here. You put them in the calculator, okay, and what do you do with them? Right, you're looking to make sure there is no pattern in the residuals. You're looking to see good scatter or no pattern, whichever way you want to look at it, okay? Because that's what you want, good scatter or no pattern. And if there's a pattern, there was one on the AP test a couple years ago that you had to do that. And you had, you generally can look at the line itself, look at the data itself, and look at the R values. That's two good ways. But if they have a residual plot over to the side, you got to make sure you include that in your discussion, or they're going to dock you points for that. Because the year that it was on there, a lot of people talked about, well, the data looks pretty linear and the R value is okay, it's strong or it's moderate, but the when you looked at the graph of the residuals, there was a parabola sitting there. So you got to check that to make sure whether or not it's actual linear. Now, what should the sum of the residuals be? What should the sum of the residuals be? Remember, the least squared regression line is the line that fits the data the absolute best. So what should the sum of all the residuals be? 0, because it's the best fit. You're going to see that on the AP test as well. They're going to ask you that question. You need to know that you've got, the line of best fit says you got just as many positive residuals as you do negative residuals. And if you sum them all up, it should be pretty darn close to 0. And I generally make my students do that at least one time on a small set of data so that they see that it does equal 0, because they don't believe me until I make them do it at least one time. All right, let's answer a couple multiple choice questions and we'll call it a day. All right, so find your data analysis questions. Let's look at a couple of those, and then we will get the heck out of Dodge. All right, so in the beginning of your packet there, when you get into data analysis, this is one of the first things that you see there. It says, given that y equals the height of a plant. So this is right in the beginning of it, right past the notes. Before the multiple choice, there's this little problem. It's on page 8, bottom of the page. Alright, now on this particular one, they have already given you the LSRL and they've already given you the correlation coefficient. Take a minute and see if you can answer those 3 questions right there. Interpret the slope and the y-intercept. Interpret the correlation coefficient. Find and interpret the coefficient of determination. Now again, you're going to have to interpret this stuff. So you need to be very familiar with those sentences. Interpret the slope and the y-intercept. Interpret the correlation coefficient. Find and interpret the coefficient of determination. All right, Lucas, you're going to predict, you're going to tell me about the slope and what it means. Let's see, what am I going to pick on too? Madeline, you tell me about the y-intercept. you can tell me about the intercorrelation coefficient. And let's see, who else am I going to go back here? Let's see, Abby, you tell me about the coefficient of determination. Now, that doesn't mean you don't have to do it, because they don't know it. I might call on somebody else.
Which one am I doing again?
So,
Stone, you got that?
okay, so I'm ready for my slope. I'm ready for it. Lucas, slope. You ought to just be able to look at it and tell me. Well, you put it over 1. Rise over run. The run is 1. Okay. We're ready. Somebody want to offer to help him? You need to phone a friend?
Yes.
Who are you going to phone to help you? Pick on somebody.
Okay, I'm going to pick someone who I know is smart than me.
Who are you picking?
Either working early.
Pick one. Morgan.
What's the question?
Slow.
As the month increases by 1, the height increases by 2.3.
No, it's a plant. Yes, you are correct. Very good. All right. Y-intercept.
If the month is 0, then the predicted value is 1.2.
Now, do you think that's realistic? Do we know? Because we don't have a data set here to look at, we don't really know if that's in our values or not. But if we have the data set, the one next question would be to look at the data set and see if it's in our data values, okay? All right, correlation coefficient.
I'm gonna phone a friend, you go for, I was kidding. No, that's,
You should always be able to phone a friend in class, always.
no, I got this, hold on. Okay, well, positive, so that means it's.
How strong is it?
I mean, it's fairly strong.
So is it weak, moderate, or strong? Those are generally the 3 words. Okay, so strong,
Yeah.
direction, positive, negative.
Positive.
All right, so there is a strong, positive, linear correlation, association, relationship. Any of those are acceptable between age in months and the predicted height of plants in centimeters. All right, coefficient of determination. Who had that?
Stone, you got it.
Okay, all right. So first of all, what's the value of the coefficient of determination?
I don't even know.
You don't even know? That is R squared. The coefficient of determination is R squared, and R squared is 0.893. And so 89.3% of the variability in plant height in centimeters can be explained by the linear association with age in months. That's what they're looking for every time. You just got to know those sentences. We practice them quite a bit. Even after we get through with it. Every test I give is cumulative. They pull their hair out, but you know, we're getting ready for exams for this semester, but the test we just took was on chapters 1 I mean, the first one's on 1 through 3, the next one's on 1 through 5, the next one's on 1 through 6. The one we're taking next week is 1 through 10. And then the exam will be on 1 through 12. But you gotta know your stuff all year round. So I keep giving them those tests so they have to keep studying what they've already done. Because if you're gonna pass the AP test, you gotta know all your stuff. Alright, let's look at 1 or 2, multiple choice, and then we're going. Alright, question 1. If the largest value of a data set is doubled, which of the following is false? False. Which one of the following is false?
Is it C?
Yes, it is. Very good.
Or
Yay, Grant.
I told me to say, I think it's D. And so I'm like, alright, it is C then.
Alright, 2. Data was collected on 2 variables, x and y, and a least squares regression line was fitted. Here's our equation. What is the residual for 0.56? So this is your y value. You're going to have to calculate y hat, which means you're going to have to plug 5 into that equation and get y hat. And then you will have to use your residual formula. Y minus y hat. Now, there's a lot of work in that multiple choice question. But that's what you're going to see on the AP test. It's not just going to be straightforward. You'll have to do a good bit of work to get to it. So you'll have to look and see what is y hat, and then subtract y minus y hat. We got an answer?
B.
B is correct.
B for boy.
B for boy.
That's probably.
Alright, this one's asked, here is a residual plot, what we were talking about a while ago. Which of the following is a correct conclusion based on the residual plot displayed? Now, you know residual plots have 0 in the middle, positives on top, negatives on bottom. Now, again, you're asking yourself, if it's a good residual, if it's a truly linear, you should have good scatter here, as many on top as you do on bottom, which we don't have here. But read those descriptions there and see if you can pick it out. Last one. Do we have an answer? Somebody give me a thought. B is correct. Too many of the residuals. Alright, one last thing you have to do. You have to put this, go in your phone right quick, go to this site, and fill out a survey. I have to tell you that. Go to this site, fill out a survey, and you are free to go. Fill out the survey. Yes.
This is the biggest time.
Stop. There might be a phone. Okay.
Remember, clean up after yourself, the floor, pick up your paper. Take some lifesavers with you.
Yeah, and the biggest. That's